All right, so get this. We're diving deep into AI today, but here's the twist.
Oh, a twist.
Yeah, so get this. Our listener is actually getting ready to make a YouTube video all about AI.
Okay.
And we have their notes and script right here.
So we're like going behind the scenes?
Yeah, it's a deep dive behind the scenes of how AI content is made.
I like it.
And we're going to tackle everything from, algorithm to neural torching machine.
Wow, that's a lot of ground to cover.
It is a lot. We'll see how far we get, but, the listener's going to get the inside scoop on what all these terms mean, right? Not just the definition, but how they connect and why they matter.
Yeah. It's like having that cheat sheet for understanding all this AI jargon.
Right.
It can feel overwhelming at times, but once you grasp those core concepts, it really does unlock a whole new level of understanding about this really incredible technology that's changing the world around us.
Okay, so let's start with the foundation. Okay,
Yeah.
like those general AI terms that everyone seems to be throwing around these days.
Yeah, the basics.
Okay, so first up, algorithm. Now, I always get this mixed up with like some complicated math equation.
It sounds complicated.
It does, but really it's just a set of instructions, right?
Yeah, a set of instructions for the AI to follow.
Like a recipe.
That's a great way to put it.
Okay.
Yeah, it's a blueprint that guides an AI system on how to perform a specific task. So you have your ingredients, which is the data, and the algorithm tells the AI how to mix and process that data to achieve a specific outcome.
I like that. Yeah, so it's like a cooking recipe.
Exactly.
You put in all the, you follow the steps and it leads to the final result.
Right.
In this case, baking a cake, or in the case of AI, maybe, recognizing an image.
Yeah, or composing a piece of music.
Okay, cool. So then artificial intelligence itself, AI, that's the system that's actually following those instructions. But it's not just about, robots becoming super smart. Is it?
No, not at all.
Okay.
Artificial intelligence is a broad term. It really refers to any system that can perform tasks that would typically require human intelligence. So things like learning, problem-solving, decision-making, those are all hallmarks of intelligence, whether it's human or artificial.
Okay, I see. So it's not, the Terminator movies coming to life.
Not yet, at least.
Okay,
Yeah.
good to know. Good to know. So then there's machine learning, or ML.
Right.
This is where I feel like things start to get a little more interesting.
Yeah.
So this is where the AI actually learns from the data, right? Like it figures out the patterns and rules without someone having to, specifically program every single little thing.
Exactly. And that's one of the things that makes it so powerful. Imagine trying to teach a computer to recognize cats in pictures with traditional programming. You'd have to define every single feature like pointy ears, whiskers, tail, and it'd be incredibly tedious.
Yeah.
But with machine learning, you feed the AI a bunch of cat pictures and it learns to identify those features on its own.
Oh, wow. So it figures it out by itself.
Yeah, pretty much.
Okay, that's pretty impressive. Okay, so then there's deep learning, DL. Now that sounds intense.
It is.
Is that like machine learning on steroids, or?
You could say that it takes machine learning to the next level by using artificial neural networks. So these are complex structures that are inspired by the human brain.
Okay.
They have multiple layers, hence the deep in deep learning, and they're capable of learning much more complex patterns and relationships in the data.
Oh, okay. So it's like, you went from, elementary school to high school to college to,
Exactly. It's like getting a PhD in machine learning.
Exactly.
Yeah.
Yeah. So that's how we get those crazy AI systems that can, write poems or compose music. Like it's almost like they're tapping into some hidden creative part of the data.
Yeah, it's pretty mind-blowing what deep learning has been able to accomplish.
Yeah, it's amazing. Okay, so even with deep learning, the AI still has to be taught, right? So that's where training data and test data come in. It's like, AI boot camp.
Exactly. Training data is like giving the AI model textbooks and lectures, and then to make sure they've actually learned something, you give them a test. And that's the test data. It's data the model hasn't seen before, so we can see how well it generalizes its knowledge.
Okay, so that makes sense. And that's where like overfitting comes in, right? Like student that, crams for the test and then the next day forgets everything because they didn't actually learn the material.
That's a perfect analogy. Overfitting is when the AI model learns the training data too.
Yeah.
Well, it almost memorizes it, but then struggles to apply that knowledge to new data.
So it's like it got too comfortable with the training data.
Exactly. It becomes too specialized and loses its ability to generalize.
Okay. And then underfitting. That's like the student who just didn't even bother to open the textbook.
Yeah, that's a good one. Underfitting is the opposite of problem, where the model is too simple and fails to capture the complexity of the data.
Okay, so it didn't study hard enough.
Pretty much.
Okay, all right. I think we're starting to get the hang of this AI lingo, but there's one term I'm still a little fuzzy on, Hyperparameter.
Okay.
Sounds very technical.
It does sound technical, but it's actually pretty simple. It's essentially the settings you adjust before training an AI model, so they control things like how fast the model learns, how much data it uses, and the complexity of the model itself.
So it's like the knobs and dials you're kind of tweaking to get the best performance out of the AI.
That's a great way to think about it. It's like adjusting the settings on a camera to get that perfect shot.
Oh, I like that analogy. Okay, that makes total sense. All right, so now for the, I think this is like the really exciting stuff, the large language models or LLMs.
Yeah, these are the rock stars of the AI world right now.
They are. I mean, they're getting a lot of buzz. Everyone's talking about them. These are the ones that can write stories and hold conversations like a human, right?
Yeah, they've got this remarkable ability to understand and generate human language. So think chatbots that can hold surprisingly natural conversations.
Okay.
Or AI systems that can write different kinds of creative text formats.
So like I've heard of BERT.
But
Is that one of these LLMs?
BERT is a great example. Yeah, so it's a pre-trained LLM developed by Google.
Okay.
And it's used in a wide range of applications, from improving search engine results to powering those helpful chatbots you see on websites.
Okay, so BERT's everywhere.
Pretty much.
Okay, and it stands for bidirectional encoder representations from transformers.
Thankfully, you don't have to memorize that.
Yeah, I'm not going to try to memorize that one. Okay, so what's the transformer part all about?
Okay.
Does this have anything to do with those shape-shifting robots?
I wish it did, but no.
Okay.
The transformer here refers to a specific neural network architecture that's really revolutionized the field of natural language processing.
Okay, so it's all about how the model processes the information, right? Like understanding the relationships between words in a sentence.
Exactly. And it allows the LLMs to focus on the most important parts of the text, just like we do when we're reading.
Oh, so they kind of have like a built-in sense of context and meaning.
Yeah, they're getting pretty good at understanding the nuances of language.
Wow, that's really impressive. And these LLMs are often generative models, right? Meaning that they can create new stuff. They're not just analyzing existing text.
That's right. Generative models can produce new text code, music, you name it.
Oh, wow.
It's how you get AI systems that write screenplays, compose songs, or even generate those mind-blowing AI art images we've been seeing lately.
Oh, yeah. Those AI art generators are something else. I mean, they're creating these like wild, surreal images, like something out of a dream.
Right. It's like AI is tapping into the subconscious.
Yeah, I know. How do they even work? Is it like magic or something?
It seems like magic, but it's actually this fascinating area of AI called diffusion models.
Okay, diffusion models, I've heard of those, but I don't really understand how they work.
So these models work by gradually refining an image that starts out as pure noise, like static on a TV screen.
Wait, so you're telling me they start with randomness and then somehow create a cleared image?
Yeah, it's kind of like sculpting, but instead of starting with a block of marble, you're starting with a pile of dust.
Okay, so it's like Michelangelo, but starting with dust instead of marble?
Exactly. And the model uses this thing called a denoising diffusion model to remove the noise step by step until a recognizable image emerges. It's like watching a blurry photo slowly come into focus.
That is wild.
Yeah.
Okay, so that's how we get image synthesis. That's that ability to just create completely new images from scratch.
Yep, that's how it works.
Okay, wow. Okay, speaking of seeing, let's shift gears a little bit and talk about another area of AI that's kind of changing the game. Computer vision.
Computer vision.
This is all about teaching machines to see and interpret images just like we do, right?
Right, so it's about enabling AI systems to see and understand visual information, from still images to videos. And it's used in everything from self-driving cars to medical diagnosis.
Wow, it really is everywhere.
It is.
Okay, so how does it work? Like if an AI is looking at a picture of a cat, how does it know it's a cat and not, say, a fluffy dog?
Okay, so this is where something called a convolutional neural network, or CNN, comes in. It's a type of neural network specifically designed for processing visual data, and it works by applying these filters to the image extracting features like edges, shapes, and textures.
So it's like breaking down the image into its like basic building blocks, right?
Yeah, exactly.
Like a detective looking for clues.
And by analyzing these features, the AI can then classify the image, in this case recognizing it as a cat rather than a dog.
Okay, so that's how self-driving cars can navigate, right? They're constantly analyzing images, they're identifying pedestrians, other cars, road signs.
Right, it's like having a second pair of eyes constantly scanning the environment.
And that's called what? Object detection.
That's right. Object detection allows the AI system to not just identify what objects are present, but also where they're located within the image.
Okay, I see.
And that's crucial for things like self-driving cars, robotics, security
Well,
systems.
this is incredible. I mean, this is all so fascinating, but I have to admit my brain is starting to feel a bit overloaded.
Yeah, we have covered a lot of ground.
I think we need like a little break to let all this sink in.
Definitely, we've thrown a lot of terms and concepts your way.
Yeah, and we still have a lot more to explore.
Exactly. AI is a vast field.
It is. But we'll be back soon to continue our exploration of this amazing AI landscape.
Sounds good.
Okay, so we've covered the basics of AI, like algorithms, machine learning, deep learning, and it's amazing how much progress has been made just in a few years.
Yeah, it's been really remarkable.
Yeah, I'm curious, like, where did all this even start? Was there like a light bulb moment when someone said, hey, let's create artificial intelligence?
Well, it wasn't quite that simple. AI actually has roots in multiple disciplines like math, philosophy, even biology.
Oh, wow, I didn't realize that.
Yeah, and in fact, one area of AI that draws inspiration from nature is something called evolutionary algorithms.
Evolutionary algorithms.
Well,
Okay, so we're talking AI that like evolves, like Darwin's finches adapting to their environment. Is that kind of how it works?
yeah, you're on the right track. Evolutionary algorithms take inspiration from that idea of natural selection, the idea that the fittest individuals are more likely to survive and pass on their traits. So in AI, these algorithms start with a population of potential solutions to a problem, and then through a process of selection, variation, and inheritance, they evolve towards better and better solutions.
So it's like AI is going through his own version of survival of the fittest.
Exactly.
But instead of physical traits, it's like the algorithms themselves that are evolving.
Right. It's like they're competing against each other to see which one can solve the problem the best.
Okay, that's pretty wild. And one of the most well-known evolutionary algorithms I think I've heard of this is the genetic algorithm.
The genetic algorithm, yes, it's a classic.
Okay, so how does that work?
It mimics the process of biological evolution using techniques like crossover and mutation to create new generations of solutions.
Okay, break that down for me. What's crossover and mutation in this context?
Imagine you're trying to breed the perfect racehorse crossover. Would be like combining the genes of two successful horses, hoping to get an offspring with the best traits of both parents.
Okay, I get that.
And then mutation would be like a random genetic tweak that might introduce a new potentially beneficial trait.
So it's like AI is playing a game of genetic lottery, trying to hit the jackpot with like the perfect combination of algorithms.
That's a great analogy.
But how do they even measure what's fit in this AI evolution game?
That's where the fitness function comes in. It's essentially a measure of how well a particular solution performs. So the algorithm uses this function to evaluate each solution and select the ones that are doing the best.
So it's like setting a goal for the AI and then letting it experiment and evolve until it finds the best way to achieve that goal.
Exactly. And the amazing thing is these evolutionary algorithms can often come up with solutions that humans might never have thought of.
Wow, that's kind of scary and exciting at the same time.
Yeah, it definitely has the potential to be both.
So earlier we talked about transfer learning, right? Where you take an already trained AI model and you fine-tune it for a new task. Is there any overlap there with evolutionary algorithms?
That's a great question. And yes, there actually is. You could imagine using an evolutionary algorithm to fine-tune the parameters of a pre-trained model, searching for those optimal settings for that new task.
So it's like taking a skilled athlete and then using an evolutionary algorithm to figure out like the best training regimen to get them ready for a specific competition.
I like that analogy. It's all about optimizing performance and leveraging existing knowledge to solve new challenges.
Okay, that's really cool. But AI can feel a little unpredictable sometimes.
Oh, yeah, definitely.
Like, what's the deal with those like weird, surreal images that AI sometimes generates? It's like, is it having a bad dream or something?
Those strange images you're talking about are actually a fascinating phenomenon known as hallucinations.
Hallucination.
Yeah.
Okay, so we're not talking about like AI seeing ghosts or anything.
No, not quite. An AI hallucination refers to an output that's not grounded in reality or the input data. It's like the AI is making stuff up, creating something that doesn't actually exist or doesn't make sense in the context of the task.
So it's like those AI-generated images that are super detailed, but they just feel off like they're from another dimension or something.
Exactly. It's like AI's imagination running wild.
Okay, so why do these hallucinations even happen? Is it like a bug in the system?
Well, it's not quite a bug, but rather a consequence of how AI models learn and generalize. I mean, we talked about overfitting.
Yeah.
Sometimes in an effort to make sense of the data, the model can extrapolate beyond the boundaries of the training data and create something that's novel but not necessarily grounded in reality.
So like AI is getting a little too creative.
Yeah, it's trying to fill in the gaps with its own imagination, which can lead to some interesting results.
Okay.
Yeah.
Interesting. But who's responsible for like guiding these creative AIs? Like who's writing the instructions and prompts for these powerful systems?
Yeah. That's where the prompt engineer comes in. It's a relatively new role that's gaining a lot of attention as AI becomes more sophisticated.
Prompt engineer. So it's not just about coding anymore. It's like you need to be an AI whisperer to get the best results.
Yeah, that's a good way to put it. A prompt engineer is someone who understands how to communicate effectively with AI systems, crafting the perfect questions or instructions to elicit that desired response.
Okay, so it's a blend of technical skills, linguistic understanding, and even a bit of creativity.
Exactly. You need to be able to think like the AI to some extent to anticipate how it will interpret your prompts.
Wow, I can see how that would be a really crucial skill as AI becomes, even more integrated into our lives. It's like learning how to speak the language of AI to get it to do what we want.
Right. And just as there are different languages and dialects among humans, there are nuances in how you communicate with different AI models. A good prompt engineer knows how to tailor their prompts to the specific model and task at hand.
So there's a whole new level of communication.
Yeah, it's a fascinating field.
It is, okay, we've covered a lot of technical terms, but there's one that keeps popping up that I'm still not quite clear on. Token. What exactly is a token in the world of AI?
Good question. So a token in AI, particularly in natural language processing, is a fundamental unit of meaning. Think of it as a building block of language that these models use to understand and process text.
Okay, so it's not just letters or words, but it's like chunks of language that carry meaning.
Exactly. And these models break down text into these tokens to analyze relationships between words, understand context, and generate meaningful responses. The process of converting text into these tokens is called tokenization.
So it's like translating human language into a language that AI can understand.
That's a great way to put it. And just like with any translation, there are different ways to break down text into tokens. Some models use word-level tokenization, where each word is a separate token. Others might use character-level or subword-level tokenization, breaking down words into even smaller units.
So it sounds like finding the right level of granularity is key to making sure the AI really understands those nuances of language.
Exactly, the choice of tokenization method depends on the specific task and the capabilities of the AI model.
So tokens are like the DNA of language for AI. They're the building blocks that allow AI to read, write, and even think in human language.
That's a great analogy, and just as understanding DNA is crucial to understanding biology, understanding tokens is essential to grasping how AI processes language.
Okay, that makes sense.
Yeah.
We've been focusing a lot on the technical side of things, but AI is also having a huge impact on the real world. Like, there's some really interesting examples of how AI is being used in creative fields like art and music.
Absolutely. The line between human creativity and AI-generated content is becoming increasingly blurred.
Yeah, I've seen some of those AI-generated artworks, and it's pretty mind-blowing.
It is. We have AI systems composing music, writing poetry, even creating paintings that are almost indistinguishable from those created by human artists.
Yeah, it's both exciting and a little unnerving, right? Like, what does it mean for human artists when AI can create art that's just as good, if not better?
It's a good question. And it raises a lot of questions about the nature of creativity, authorship, and the future of art itself. But one thing's for sure, AI is a powerful tool that's expanding the boundaries of creative expression.
And it's not just about creating new art.
Right.
AI is also being used to analyze and understand existing art in new ways.
That's right. AI can be used to identify patterns in art history, analyze the emotional impact of artworks, even restore damaged paintings. It's giving us a whole new lens through which to appreciate and understand human creativity.
Wow, so AI isn't just a tool for artists. It's a tool for art historians, museum curators, even art restorers. It's like AI is becoming an art expert in its own right.
It's a fascinating area of exploration, and it really shows how AI is not just about replacing human skills, but about augmenting and enhancing our own capabilities.
That's a good point. It's not about replacing us. It's about working together. Okay, well, we've covered so much ground in this deep dive, from algorithms to hallucinations, from tokens to art-generating AIs. It's remarkable how far AI has come. And I can't help but wonder, what's next? What other, exciting developments are on the horizon?
Well, that's the beauty of AI. It's a field that's constantly evolving with new discoveries and innovations happening all the time.
So there's always something new to learn.
Always.
Well, I don't know about you, but my brain is officially full.
I hear you.
We need another quick break to process all of this amazing information, but we'll be right back for the final part of our AI adventure. All right, we are back and ready to wrap up our deep dive into AI. Learning about all these different concepts and how they connect has really been eye-opening.
Yeah, it's like we've been piecing together this giant AI puzzle, seeing how all these terms and techniques fit together.
Yeah, to create this powerful and rapidly evolving field.
It really is evolving at an incredible pace.
It is. And it's not just some abstract concept anymore.
Right.
It's having a real impact on the world around us. From how we work to
Mhm.
how we create art and even how we understand ourselves.
I think that's a really crucial point. AI is no longer just this futuristic idea. It's woven into the fabric of our lives, often in ways we don't even realize.
Yeah, that's true. And, as AI becomes more powerful and more pervasive, it's important to understand its limitations as well.
Absolutely.
And speaking of limitations, there's one term that I've heard, in discussions about AI that I'm still not quite clear on: black box.
Yeah, the black box.
What exactly does that mean? Is it like some secret code or?
It's not a secret code, but it can feel a bit mysterious.
Yeah.
The black box problem in AI refers to the fact that, it can be difficult to understand how some AI models, particularly deep learning models, arrive at their decisions.
So the AI is making decisions, but we don't always know, like, the reasoning behind those decisions.
Exactly. The inner workings of these complex models can be opaque, even to the engineers who design them. And this lack of transparency can be a real challenge, especially in situations where it's crucial to understand why an AI made a particular choice.
Right, like in healthcare or finance.
Exactly. Those are high-stakes areas where we need to be able to trust the AI's judgment.
Yeah, and understand why it's making those decisions.
Right, and that's why researchers are actively working on techniques to make these AI models more interpretable and explainable.
So more transparent.
Exactly. It's all about shedding light on that decision-making process so we can build trust and ensure that AI is used responsibly.
So opening up that black box and making sure everything inside is working as intended.
Exactly.
Okay, and speaking of trust, there's another term that kind of comes to mind when to think about AI's impact on the world: singularity.
Ah, yes, the singularity.
Is this like the point where AI becomes super intelligent and like takes over the world? I've seen that in a few movies.
Yeah, the singularity is a fascinating concept, and it definitely captures the imagination. It's that hypothetical point in time when AI surpasses human intelligence and triggers this rapid acceleration of technological progress,
Okay.
leading to really unpredictable changes in society and even human evolution.
So like a point of no return where AI becomes the dominant force on the planet.
That's the kind of dramatic version often portrayed in science fiction.
Right.
But the singularity is more of a thought experiment.
Oh.
A way to explore those potential long-term implications of AI development. There's really no consensus on whether or when it might occur, and it's likely to be a much more gradual and nuanced process than that sudden dramatic shift that we often see depicted.
Okay, so no robot overlords anytime soon.
Hopefully not.
Okay, good to know. But it's still a thought-provoking concept.
Oh, definitely.
It highlights the importance of thinking carefully about those long-term implications of the technology we're creating.
Absolutely. AI is a powerful tool, and it's up to us to guide its development in a way that benefits humanity.
Well, I don't know about you, but I feel like I've learned a whole new language in the past hour or so.
It's been quite a journey.
It has, from algorithms to the singularity. It's amazing.
We've covered a lot of ground.
We have. And, AI is this incredibly fascinating field, and it's rapidly evolving, and there's always more to learn.
That's the beauty of it.
It is. So for all of you listening out there, keep exploring, keep questioning, keep learning, because the future of AI is being shaped right now, and it's a future that we all have a role in creating. So thanks for joining us on this deep dive into the world of AI, and we hope you've learned something new today, and maybe you sparked a new passion for this incredible technology.
And remember, this is just the beginning.
It is so. Until next time, keep exploring.
Yes. Disclaimer, as an AI-generated content channel, we strive to provide accurate and up-to-date information to our viewers. However, please be advised that due to the nature of our content generation process, some of the information we provide may be misleading or incorrect. We strongly encourage our viewers to use our content as a starting point for their own research and to consult with relevant professionals before making any financial or business decisions. We are committed to constantly improving our AI system to ensure the highest quality of information possible, but we cannot guarantee the accuracy or completeness of the information provided. Thank you for your understanding.